So today's lesson on 3.3, solving systems of inequalities by graphing, is going to take the earlier lesson about graphing inequalities and combine it with the ideas about systems. So just quick review, when we solve systems of equations, we're looking for a single point where the two lines intersect. But when we graph inequalities, we have a shaded region that's our answer. So what we're going to be looking for here is where our shaded regions overlap. So we're going to go ahead and we're going to graph normally. So we are going to take this first inequality of y equals 2x minus 3, and from that we know that our y-intercept is negative 3 and our slope is 2 over 1. So we plot at negative 3 and we go up 2, right 1, up 2, right 1. Now remember, less than or equal to is a solid line. So now I have to figure out which side to shade. So if I go ahead and do my test point, and I test to see if 0, 0 makes this true or false. So is 0 greater than or equal to 2 times 0 minus 3? Is 0 greater than or equal to negative 3? That's true. So that means that this inequality is true on the side that contains 0, 0. So that's what we've been doing. Now I'm going to go ahead and graph the other one, here in blue, which has a y-intercept of 2, and it has a slope of negative 1 over 1. So I'm going to go ahead and graph at 2, and I'm going to go down 1, right 1, down 1, right 1. This time I have a less than sign, so I have a dashed line. I'm going to go ahead and test my point of 0, 0 to see if that makes that inequality true or false. And so I would have 0, is that less than negative 0 plus 2? Is 0 less than 2? That also is true. So I shade this side of my graph. So what my answer is, dashed on this side to right here, then solid, and it's all of this overlapping region. And this graph represents my answer solution set. If we go ahead and look at another example, already in slope-intercept form, we have an intercept of 1, we have a slope of negative 3/4. So I go ahead and graph at 1, I go down 3, 1, 2, 3, right 1, 2, 3, 4, or up 1, 2, 3, left 1, 2, 3, 4. This is a less than or equal to, and so I'm looking at a solid line. I go ahead with my test point. Remember, you can use any point you want that is not on your line, solid or dashed. Is 0 greater than or equal to negative 3/4 times 0 plus 1? Is 0 greater than or equal to 1? Well, that's false. So that means I don't shade the side including that, I shade the opposite direction. Because everything on the same side of 0, 0 is going to make it true or false. So everything on the other side will make it true. If we go ahead and graph this one with a y-intercept of negative 2 and a slope of negative 3/4, go down 1, 2, 3, right 1, 2, 3, 4, up 1, 2, 3, left 1, 2, 3, 4. I'm less than or equal to again, so I have a solid line. Now immediately I notice that I have, or I should have noticed as I was doing this, I have parallel lines because I have the same slope. My graph represents that. What's going to matter now is where I shade. So I'm going to test with my 0, 0 point, and is 0 less than or equal to negative 3/4 times 0 minus 2? Is 0 less than or equal to negative 2? Well, that's false. So I'm going to end up shading on this side, And since there's no overlap, this is no solution. Now, I could have had a solution if I shaded up because they would overlap. So don't assume that parallel lines are always no solution for inequalities. Now, the next example is a real-world example. Medicine professionals recommend that patients have a cholesterol level below 200 milligrams of blood and a triglyceride level below 150. Write and graph a system of inequalities that represents the range of cholesterol levels and triglyceride levels for the patients. Let C represent cholesterol and T represent triglycerides. So on our graph, we happen to have the triglycerides as our x-axis, the cholesterol as our y-axis. If we go to represent these in terms of a graph, cholesterol below 200 means that your C must be less than 200. Not that it's less than or equal to, must be less than. So that would include all, notice dashed lines, of your values and below. Now, our triglycerides, our T's, must be less than 150. And that would indicate everything less than on this side. Now, we don't have any negative numbers because this is a real-life situation that negative numbers wouldn't make sense. So our solution region for these combined values is in this area right here. And that is a pretty straightforward word problem. Now, one other thing we can do with inequalities is we can go ahead and find the vertices of a figure, meaning the corners. Now, if I have 3 inequalities, I'm pretty sure that's going to become a triangle. So if we look at this first one, it is not in slope-intercept form, so I need to solve it. So I'm going to have negative y is greater than or equal to negative 2x minus 1. I'm going to multiply by negative 1, or remember what I need to do there. Y is less than or equal to 2x plus 1. So now I have my y-intercept is 1, my slope is 2, and I can go ahead and graph that. So remember slope 2 over 1, up 2, right 1, down 2, left 1. It's less than or equal to, so this is a solid line. Since I'm looking for the vertices of a polygon, I don't need to worry about shading because I need to make the figure. So if I look at the next line, also not in slope-intercept, so subtract x from both sides. So now I have a y-intercept of 4, and I have a slope of negative 1 over 1. Down 1, right 1, down 1, right 1. And I have a line that cuts down like this. My last one, subtract x from both sides, greater than or equal to negative x plus 4. Divide everything by 4. Y is greater than or equal to negative 1/4 x plus 1. So my slope is negative 1/4. My y-intercept is 1. So here's my 1, and I'm going to go down 1, right 1, 2, 3, 4. Up 1, 1, 2, 3, 4. And here's my line. And I've clearly made a nice triangle right here. And then I can easily go in and identify this vertice is at 1, 3. This vertice is at 4, 0. And this vertice is at 0, 1. And those are the 4 vertices of my polygon. That is the lesson on systems of inequalities. Good luck with your homework.